Hello guys, today we're going to start with lecture 9 and we're going to take Boolean Algebra Simplification, where we simplify the Boolean expression using some Boolean identities, rules, let's say. And we took in lecture 8, we started the Boolean Algebra. We took basically what's a transistor, which is a base building block of any electrical device, a switch on off. On a next layer what comes gates. From transistors we can build gates. We took 6 types of 6 gates, or we can say logic operators: and, or, NAND, NOR, NOT, and XOR. There's 3 ways to describe logic or a circuit. We can describe it using a Boolean expression, an equation, logic diagrams, and truth tables, and we saw how we can convert between them. One of you might ask now, and why are we taking all that logic? We're talking about the hardware. Why is it related to assembly? Remember, assembly is a lower level programming languages. It's near the hardware. In between high level languages and hardware, nearer to the hardware. So that's why we need to understand the hardware, the logic, how a machine is built, implemented. It's going to be really important in understanding assembly language. So let's start with the simplification. With the simpler that we can make a Boolean function, a circuit, a Boolean function, a Boolean equation, the smaller the circuit that will result. If I have a smaller circuit, we'll use a lower number of gates. Lower number of gates meaning price went down, lower number of gates, and heat is also an important factor. And smaller circuits are usually faster. Simple circuits are cheaper to build, less number of gates, consume less power, and run faster than complex circuits. That's why simplification is really important. And there's 2 ways: using the identity rules that we're going to take in lecture 9, and there's a way where we use K-maps, and we'll see what K-maps in lecture 10. So 2 ways. Let's check the identity rules. There's lots of rules, but mainly those are the most important. The identity law, where I have 1 x equals x. X meaning, here think of it as 0 or 1. 1 multiplied by 0 and it, this is an AND. 1 and 0 is going to give me 0. So 0 and 0 are the same. 1 and 1 is going to give me 1. So really it depends on x. The AND depends on x. Here's the OR. 0 or 1 is going to give me 1. 0 or 0 is going to give me 0. So it depends also on x. Here's an AND 0, and x is going to be always 0. Even if I had 1 here. 0 and 1 is going to give me 0. 1 and 1 is going to give me always 1. Even if it was 1 or 0, 1 or 1 is going to give me 1. XX. And here's what I recommend. Best thing to do. Always, you only have 2 values. This is what makes it really easy. 0 and 1. Just substitute those 2 values. Here I have XX. Think of it. If I had 1, 1, what's it going to give me? 1. If I had 0, 0, it's going to give me 0. So XX is x. X or x. 0 or 0 is going to give me 0. 1 or 1 is going to give me 1. X and the invert of it, x and not x, it's going to give me 0 always. And if x was 1, not x will be 0. This will give me 0 x, or not x will give me 0 or 1, 1 or 0. This is going to be 1. Identity name here we have also, this is a really important one. This is really important, where we have x and parentheses x or y is gonna equal x, and y is that. Let's see, what do we do if we want to solve this? We distribute. So I have x, distribute this and this, x or x y, or this is or, and what does this equal? This is going to be x, this is x, xx is going to be x from this, xy is going to be or x y, and what's this? Now can I take the x outside, or what do we do? Here's the law: x or xy equals x. How did I do this? If I take x as common, I'm gonna be left with 1 or y. 1 or 0 is gonna give me 1. 1 or 1 is gonna give me 1. So this is gonna be always 1. So my answer will be x 1. This is x and 1. This is x and 1. If x was 0, it's gonna give me 0, so it's gonna give me x. If x was 1, it's gonna give me 1, meaning also x. So it actually equals x. This equals x. So this proves both of those. Here this x, we took the x common. I'm left with 1 plus, or 1 or y. 1 or y equals 1. X and 1 is x. De Morgan's is another really important one. If we have a De Morgan, this is what? This is a NAND gate. Think of it as a NAND gate, an AND with a NOT on both of them. This is not an AND gate. If I had this, each one on a separate one. No, this is, and this is why. Think of this as well. This is not, it has to be on both of them, the comment or the NOT. So what does De Morgan states? If I have an AND or this, we distribute the comment. So I'll have what? X and y, we distributed the comment, and we change the sign. Here I have and, I change it to or. So this is the result. Distribute the comment and change the sign. So if I had an or, this is an or. We distribute the comment. Sorry. And I change the sign to and, which is this. This De Morgan is really important. X not equals x, or x comma 2, meaning I'll have x, say it's a 0 or a 1. I put it in an inverter. It's gonna give me what? For this, it's gonna give me a 1, and for this, it's gonna give me a 0 for the 1. Now I invert it again. You can put a circle here. This is gonna give me 1. It's gonna give me a 0, and 0 is gonna give me a 1. So a double inverter will give us what? The same value actually. X double comment or double invert equals x. So let's go now and see examples. Let's simplify this using simplification. rules. I have C, or what's this? This is an AND gate, a comment. So we apply De Morgan. De Morgan, what does it say? Distribute the comment. So I'll have C naught, B naught, and change the sign. And I change the sign and to an OR. What can I do now? We distribute this. Oh no, this is addition, sorry. An OR, okay? So I'll have C or C naught. So what will this equal? C or C naught? If this C was 0, C naught will be 1. If C was 1, C naught will be 0. And this is and an OR. An OR. Both of them are going to give us 1. So this equals 1, or B naught. Think of B naught. If it was 0, it's going to give me 1 or 0. It's going to give me, sorry, it's going to give me 1 or 1 is going to give me 1 also. So answer is 1, true, meaning this circuit is going to give me true all the time. Now let's see, this is another example. We have A naught. What do we do now? Always try to start from the left. I like to do that. Don't even look at the others before we distribute. I'll have A naught or A naught A and A naught B. The comma, this is meaning A naught. So this equals what? 0 and 1. If A was 1, A naught, or if A naught was 0, A will be 1. If A naught was 1, A will be 0. Both of them will give me 0. So this will equal 0. This, it doesn't change. So now let's see what we can do also. I can change this to what? 1A. This equals A, and then I'm going to distribute with this and see what. So I have 0, A, and this. Okay, now I'll get rid of the 0. It's not going to make a difference here, but now I distribute here. This is multiplied by this, and this. So what will I have? BA plus BA plus B naught, B plus AA plus AB naught. BA, this with this, and BB naught plus AA plus AB naught. This is gonna equal what? 0. This is gonna equal A. So I'm left with what? And this is 0. I'm left with BA, AA. This is gonna be A. So now we'll have this. This is really important. Think what can you do here? You can take either what? A as common here. We'll have A, and you're left with what? B naught or B, and this is gonna always equal what? 1, because it's an OR. If it was an AND, it'll be 0. 0 or 1, it's gonna be 1. 1 or 0, it's gonna be 1. So A1, and this equals A. So or this equals A. What else? A or A is gonna be A. Let's see how this goes. We can apply they didn't start it, but I'm gonna divide it into two steps here. You're gonna see how I do it in another way. This applies same rule as this one, the one I said is really important. X or xy equals x. AB or A is gonna be A. AB or B is gonna be B. Be careful. So this is gonna give me A. This is gonna be A. Then I take it with this same BA or A. It's gonna be A again. This can be A, yeah. And this A, B, not A is gonna be also A. It's gonna be also A. So this is A. The answer for this is A. That's if I started from here. But now let's go do it from this way. And what did we do? From the left. And here I took. Okay. Oh, it's not. Why did I see a B not? A not and A. We took B as common. So what's this gonna give me? 1. So I'll have 1 B, which is B or A. So what do you think? Did it change the answer? But we didn't finish. We had here what? B or A. B or A. Here what happened is we forgot this one. Got to include it. So here I'll have AB, I'll have this or A, and take this out, or A, B, no. So B or A or A, B not, and this is gonna equal what? A. So B or A. Did you see how it changed the whole answer? Oh, 1 minute here they took. Okay, they did this. I did this step here. So this is A. Okay, I can take this as A. But what? Taking it as common, change the whole answer. We got, which one is more simplified? Is it B or A, or is it A by itself? And remember, why do we simplify? We want less gates. Here I have a gate, or here I don't have any gates, just the A, the input. So that one was more optimal, let's say. Here's both ways, and this is gonna, oh no, this is not A. This is gonna be A, not B or A. I forgot, this is not. I thought the B had the complement, not the A. But this is right, so what can we do in this one? Can we simplify more? This one? No, I can't do anything with this, and I can't do anything with this. So this is the one more optimal. Here's our third example, and here this is complement on all of this. This complement is only for those, this one, and this one is only for the C. Here same thing, this is for all of that, and this is only for those, the E or F, and this is for the F by itself. And what do we do here? What do you think can we do? I think this should have been here, but I'm not sure. I think this should have been here, but let's see. We can do it both ways. I have here De Morgan. What do? Distribute the complement and change the sign. So I'll distribute it between what? Let's do it between this and this first and see what happens. So now I'm gonna have A plus B, C complement and a complement, and I change this to an AND, and I'll have two complements on this. Yeah, here I distributed this one, and I changed this sign to AND. And this one, what happens? Double complements will go on both, because those are on all of them. Here, can I do that? No, because this is, if this was on the D, yes, I can do it. If not, no, we can't do it. If it's not on the D, no, it has to be on the D to take them both. So I took this out. What will those two red ones? I'll have A or B, C not left, and what? E, D, and parentheses E or F not. And what can I do with this now? I can distribute this one on this sign. So what will I have? D not, and I distributed this. See, I distributed the AND, the one in between those. The AND here, that's the only one I distributed. I changed, so now I have D not, and I have here double complement. What can I do with this? Both of those will go with each other. It's going to be the same. Remember, A or X complement equals A. Same thing, double complement. Not going to change the answer. So I'll be left with E or F not. Can we do anything more here? We can by just what? Distributing, but it's not gonna gain anything because we don't have any similarities between those. So this was mainly simplifying using the identity rules. And guys, please don't think 3 are enough. Don't think you're good in it if you finish just 3. I think you need around 20 problems. Try to solve 20 problems, you'll be really good. They're fun. They're not going to take that much time. But remember what Einstein said, 99% depends on what? Practice and experience, and 1% depends on smartness. So please practice those. Those are really fun. If you have any questions, if you want me to put more practices, I can put more. But I'll post 10 in the description section. You can solve them. If you have any questions on them, please let me know. Thank you.